Okay, hello. Okay, apologies, I look a little bit jaded. I had to get up at 4 a.m. this morning in order to get my flight to get here. So I'm here for a few hours and then I fly back home. That's the nature of the role that I have. So I have the world's best job. GridGain pays me to talk about open source. How cool is that? Okay, great, thank you. Thank you. So I'm an old guy, as you can see, gray hair, white hair, no hair. So I've been around for a long time, worked in a variety of different environments, started life as a developer and then pretty much done everything over the years. And these days, as I said before, so GridGain is a company behind Apache Ignite. Any Ignite users here? Any Igniters? Great, a few of you. Hopefully a few more will be interested by the end of this talk. So one of the things that we have today is this whole open source movement. And so GridGain donated Ignite to the Apache Software Foundation a few years ago. It's a top-level project, very active in terms of the dev list and the user list. Okay, so I encourage you to have a look at that, download it, try it. And it started life as an in-memory data grid. And there are some commercial products out there. You may be familiar with Hazelcast. You may know about Oracle Coherence, for example. And Ignite is a key value store as well. Again, you may be familiar with some other products in this space. Redis, for example, is a fabulous, very fast, super fast product as well. But one of the things that I think we have, particularly when building distributed systems, is that it imposes all sorts of issues and problems for us. And there are some architectural choices that we need to make because building distributed systems is hard. Ignite can do so much for you. It can help you to some degree. It can take intelligent decisions. It can partition data, distributed it. But there are some intelligent decisions that you can make as well in terms of how you want to, there are some useful things that you might want to run. For example, co-location, which is one of the things we'll talk about. Okay, so just 3 issues. Because of time pressures, I mean, there's really only 3 main issues that we can discuss. Of those, the first 2 I'll talk about. The third one I'll leave for you. Again, if you want to discuss that, feel free to drop me an email. It's just my first name dot last name at gridgain.com. So partitioning, okay, so we'll look at that. Pitfalls of even distribution, which is one of the things that you might think about doing, not necessarily useful in all circumstances, could work very well in some situations. And then affinity co-location, okay, so this idea of co-locating data is an architectural decision that you have to make because, you can't beat physics, okay? I mean, there's only so many ways that you can co-locate data, and if it's co-located in one particular way, you can't do it another way, okay? So it's intelligent choices, again, in terms of what you want to do, how you want to run your queries. And the last thing, again, fairly technical, and what I'd encourage you to do is have a look at the webinar by my colleague, Dennis Magda. He's actually my boss. Dennis is the PMC for Ignite at the Apache Foundation. Did a wonderful webinar recently where he drilled down into that in a lot of detail. Okay, so if you're really into low-level stuff, looking at sort of NEO, NIO, that kind of thing, have a look at that webinar. Okay, so quickly then, let's move on. So typically then, what we have, because Ignite is a hashed partitioned map, that's really what it does. When we want to do an operation in terms of putting the sort of a key and its value, apply some algorithm to that, and if we've got a cluster, how does it actually, what actually goes behind the scenes in terms of how the data are distributed? We just apply some algorithm, and generally that's all we need to do, okay? So data are partitioned for us. It's taken care of for us. We don't need to worry about that. The other thing, though, is that generally we might think that kind of balanced partitioning might be a good thing. We use some kind of naive function. It distributes things evenly across our cluster. Here we've got a very, very simple sort of 2-node cluster, in which case we can see that we've got 6 partitions on one node and 6 partitions on another. That seems fairly reasonable. However, if we add more nodes, in this case we've added a 3rd node, then there are some issues in terms of data distribution. Okay, so there's a bit of shuffling going on. This is not necessarily what we want, because what we want to try and do within a distributed environment is reduce the amount of data that gets shuffled around, reduce the amount of network traffic, bring the processing to the data, and try and limit the amount of sort of noise, if you like, that's going on. So this is maybe one kind of naive way we might want to do this, but not a very good one. Okay, so Two approaches. Possibly you're very familiar with this, those of you who are very sort of technical and have a deep sort of understanding of distributed systems and hashing algorithms. So consistent hashing, so that's the sort of fairly standard approach, and then rendezvous hashing. Thank you. That's the approach that's used by Ignite. So in this approach, what we're trying to do is really leave it up to Ignite to manage that for us. So when we've added a third node in this particular scenario, you can see that actually there's far less that's actually being moved around. Okay? It's unbalanced, okay, but that's okay. I mean, the thing is that eventually what will happen is that as data new partitions created, nodes go down, nodes are added, the thing will take care of itself. I mean, that's the key thing here. It isn't necessarily the case that we want an entirely balanced network. Okay, very quickly then, in terms of co-location, well, one of the things that Ignite allows you to do is this very useful feature about co-locating data. So you can run queries together. So great example would be if you think back in time about 5-6 years ago, you know, the hurricane that hit New York, this weather alert that we could have sent out. So if we co-locate people that live in the city with the city itself on a particular node, we went and sent out a weather alert. Very, very easy to do because we know exactly where all the data are. That's a useful feature. Here we've got an example of being able to you know, do debit and credit across two sort of bank balance and two accounts where we're taking one from one account, adding to another account. These might be distributed across these two nodes. That involves an awful lot of messages. Up to 16 network operations, particularly if we've got things like two-phase commit as well, where we do, you know, prepare and commit messages, acknowledgements, and if we've got both primary sort of partitions, backup partitions as well, and even for a sort of two-node cluster, that's quite heavy. So one of the things that we can do, again, co-location helps achieve and reduces the amount of traffic that we need to worry about. And we can reduce this back down to sort of 4 network operations in this simple case. So we've got one node, okay, we've got this one-phase commit as well. Some of you might be familiar with that. We can take advantage of that because of the particular architecture that we've got in this approach. Okay, so the upshot, and as the light, you know, as they say, the lightning talks, you know, because there's only so much that we can cover. So key points here. Partitioning. It's not just about even distribution, okay? There are other distributions that can work quite effectively, and we don't need to worry too much about that because over time, things will balance out, and that's okay. Affinity co-location, golden concept of distributed systems, okay? Very, very useful feature for particular types of processing, but again, architectural choices, business model that we need to think about that from that perspective. But again, Ignite can help us in certain respects. And again, this is kind of a general principle for a lot of other distributed systems as well. And the third point, as I mentioned before, that goes into too much detail, is pretty deep, and unfortunately today, because of the sort of time pressures, we're just unable to cover that. Okay, time for a question, I think.
All right, as usual, time for one question. So anybody? Yes.
Okay, great.
For what kind of real world workloads do you see that Ignite is utilized mostly?
Okay, so the question was, what kind of real-world workloads is Ignite used for? And I think my best answer with there is pretty much everything. So if you check the Apache website, ignite.apache.org, there are case studies, all sorts of verticals, everything from financial, healthcare, IoT, many, many different types of applications. One of the ones that I had the privilege to look at just late last year was a company called eTherapeutics in the UK. So they're doing genomic sequencing and looking at you know, a lot of this kind of medical type of applications. They're running Ignite in parallel because they've got certain types of processing which, you know, using this parallelism gives them almost 2 orders of magnitude performance boost. And because it's a competitive area, they need to be able to run their jobs and do the kind of the type of processing very, very fast. So I would say pretty much anything and everything. There's a whole range of applications. Feel free to drop me an email. I can follow up with you, or have a look at the Ignite website where lots of case studies. You know, top name companies as well, Apple, Microsoft, and others are using it for a whole range of different applications.
All right. Thank you so much, Akmal.
Great. Thank you.